Hi, welcome to Quick Add Maths about polynomials, factor and remainder theorems. Let's start by getting acquainted with some of the terminologies for polynomials. An ax plus b expression has 1 degree and is linear. In the case of ax squared plus bx plus c, it has 2 degrees and is quadratic. When the x components become a cubic, it has 3 degrees and is also known as cubic. And finally, when the ax to the power of 4 component is available, it is 4 degrees and is quartic. Do also note that orders of the same kind can be added or subtracted, as in the example where the x to the power of 3 components can be summed together, and the x to the power of 2 components can be summed together as shown. And in the case of multiplication, its constants and variables are separately multiplied. As in example, 2 will multiply by 5 to form 10, and separately the x cubed will multiply by x squared to form x to the power of 5, and so on. Now let's get on board tutorial question 1, where for the defined function, we are to find the different 4 mathematical operations. For the first, it's summing fx with itself, and that leads to the solution being 4x squared minus 2x. The second is about multiplying x with fx, which leads the solution to being 2x cubed minus x squared. The third involves multiplying fx against itself, and this expands to the solution being 4x to the power of 4 minus 4x to the power of 3 plus x to the power of 2. As for the fourth question, it's a composite function where you would position fx into fx as shown in the working. We shall now switch gears and talk about division involving polynomials and factor theorem. As an example, we will be choosing to simplify 3x to the power of 3 plus 8x to the power of 2 plus 3x minus 2, this being divided by x plus 2. Here you can choose to perform the long method or the short method of division. In this case, I shall just show the short method, whereby it leads to the solution being 3x squared plus 2x minus 1 without a remainder using the algebraic method. Now, just as in 10 divided by 2 equals 5 can be stated as 10 equals 2 times 5, 3x cubed plus 8x squared plus 3x minus 2 can be stated as being equal to the product of x plus 2 and 3x squared plus 2x minus 1. We can further factorize the quadratic portion for this to be equal to the products of x plus 2, x plus 1, and 3x minus 1. From here, we can state that x plus 2, x plus 1, and 3x minus 1 are factors for the cubic polynomial, just as in 2, 3, and 5 are factors for 30. From the factors, you could essentially be stating that x is equals to minus 2, minus 1, and a third. Incidentally, when you place these values into the x portion of fx, fx would result to being 0. This is the essence of factor theorem. In summary, if fa equals 0, x minus a is a factor of fx. Tutorial question 2. Show that x plus 1 is a factor for the cubic polynomial using the division method and the factor theorem. In the division method, you would divide the cubic polynomial by x plus 1, and it should give you a result without a remainder. As with factor theorem, you would take the x value, which is -1, and insert it to the fx equation and solve for fx. This leads to fx being 0, implying directly that x plus 1 is a factor of the cubic polynomial. Tutorial question 3. Find the value of a when x plus 1 is a factor for the given cubic polynomial. When it is said that x plus 1 is a factor of the cubic polynomial, f minus 1 will equate to 0 by expressing the cubic polynomial with its x replaced by -1. That equation must equal to 0. This allows us to then solve for a. Tutorial question 4. Express b in terms of a when x minus 2 is a factor for the given cubic polynomial. Once again, when it's said that x minus 2 is a factor of the polynomial, f2 is equal to 0 by inserting the values of 2 into the given cubic polynomial. This should be equated to 0, and from there we would be able to solve for b in terms of a. Tutorial question 5. Find the values of a and b when the given quadratic polynomial is a factor for the given cubic polynomial. Here we can start by factorizing the quadratic polynomial, this being equal to x plus 5 and x minus 3. With these two being factors of the cubic polynomial, it directly means that f minus 5 is equal to 0. That allows us to set up the first equation of 2a minus 5b being equal to 95. By doing same, for f3 being equal to 0, we will have the second equation, 2a plus 3b being equal to minus 57. With the formulation of the two simultaneous equations, we could simplify 1 by dividing it by 5 for it to express b in terms of a. Then substitute this into 2 to solve for a being 0. And by stating a being 0 back into equation 3, we will be able to solve for b being equals to minus 19. Tutorial question 6. Identify the factors of the given cubic polynomial where no other hints are provided. Firstly, the only probable factors for the above are x plus 1, x minus 1, x plus 3, x minus 3, x plus 5, x minus 5, x plus 15, and x minus 15, as the number on the right of each bracket must be a factor of 15. In using the trial and error method, you will try each of the stated in succession until you locate one where fx is 0. Let me expand on what I've just said. You want to start by equating the given cubic polynomial as fx. You will then go through a series of validations as part of the trial and error method. In this case, I'm choosing to first perform f minus 1 to identify its solution, which in this case is 24. This solution being not 0 means that x plus 1 is not a valid factor. Next, I'm going to perform f1, which in this case is 0, and this directly suggests that x minus 1 is one of its factors. You could go on to perform this validation for all of the remaining numbers, and upon doing that, you would find that f minus 3 and f5 would have the solutions as 0, which directly means that x plus 3 and x minus 5 are factors of the given cubic polynomial. Alternatively, you can perform a division after locating the first factor to get to the remaining factors through a factorization method. Tutorial question 7. Fx is a cubic polynomial where the coefficient of x cubed is 2. Find fx when the roots of fx is equal to 0 are minus 0.5, 2, and 4. From the given roots, we can safely state that its factors are 2x plus 1, x minus 2, and x minus 4. Therefore, fx is the product of 2x plus 1, x minus 2, and x minus 4. You could now expand on the product to get to the required cubic polynomial. Next, we'll talk about the remainder theorem. As an example, we shall perform a division of the cubic polynomial by x plus 2. This leads to the solution being a quadratic polynomial with a remainder of 4. Do note that when we were to solve for f minus 2, it also leads to 4. Therefore, what it means here is that by inserting the value of a from a minus 1, if the end result is 0, x minus a is a factor. And if the end result is not a 0, the resultant value is the remainder 4 when the polynomial is divided by x minus a. Tutorial question 8. Find the remainder when the cubic polynomial is divided by 2x minus 1. It is straightforward. We would insert 0.5 as the value of x for fx, and this will lead us to the remainder being 2. Tutorial question 9. When the cubic polynomial is divided by 2x minus 1, the remainder is minus 4. Find the value of c. Basically, this is saying f 0.5 is equal to minus 4. By making each of the x values of the cubic polynomial to being 0.5 and equating this to minus 4, we could then solve for c. Tutorial question 10. For the given fx, it has a factor x minus 1, and when divided by x plus 2 leaves the remainder of 3. Find the values of a and b. The portion of the statement that states x minus 1 being a factor would set up the equation f1 being equals to 0, allowing us to form the first of two simultaneous equations, which is a plus b equals to 4. The second statement that talks about x plus 2 leaving the remainder of 3 will allow us to put up f minus 2 being equals to 3 to allow the setup of the second simultaneous equation as being 4a plus 2b being equals to 16. As in the usual techniques for solving simultaneous equations, we could multiply the first simultaneous equation with 2 to form this third simultaneous equation. And by subtracting the second equation with the third equation, we could solve for a being 4. By inserting the value of a into the first equation, we could easily solve for b being 0. That's all for the subject of polynomials, and if you found this useful, do look out for our other tutorials.